Hello, my name is Justin Tobias. I'm a professor of economics here at Purdue University. I am really excited to talk to you today about Econ 571. 571 is a course in econometrics. It's a required course in our new hybrid master's program at Purdue. And what differentiates 571 from some of our other econometrics courses that we offer in the program is it's a little more theoretical in focus than the others. It does have a degree of application, to be sure, but the charge of this course is really to provide the student with a rigorous and thorough understanding of the linear model and going beyond some nonlinear models as well. This course should also be extremely useful to students considering the PhD in economics. It provides a very useful and rigorous mathematical foundation that will certainly underlie all future coursework at that level. So with that said, let's go ahead and review some of the topics that are covered in 571. The first set of topics involves a statistics and probability theory review. There we start very naturally. We'll talk about random variables, both scalar random variables and joint random variables. Move on to talk about mass functions and density functions to describe their behavior. Moments in that context, so things like means and variances and higher order moments, both in scalar, joint, and conditional situations. We'll review different convergence concepts. We'll lead into estimation, enumerate some desirable properties associated with estimators, things like consistency, convergence and mean square, and convergence and distribution. Once we have that under our belt, we'll move on to also review some topics in linear algebra. Some students may be familiar with these topics, others less familiar, but we'll begin by just introducing and defining things like vectors and matrices, as well as elementary operations on those, addition, subtraction, and multiplication. Move on to talk about some other properties, traces, transpose, rank, what's it mean for a matrix to be full row rank or column rank, matrix inverses and different procedures for calculating the inverses of matrices. What does it mean for a matrix to be positive definite or positive semi-definite as an example, and how are those things in that set of matrices useful in econometric applications? And lastly, talking about solving systems of linear equations via linear algebra. The goal of this section, again, is for many students, they come into the course with a good understanding of what happens in the simple regression model. If I just have an intercept and a slope, I know how to take my first order conditions and to solve the system analytically, but when I move beyond that, and I now have 5 variables or 15 or 2,000, it certainly is a black box. I know that the computer can somehow give me answers to those questions, but I really don't have a good understanding of what's going on there. And in order to understand those fully general cases, an arbitrary regression case, this linear algebra is a necessary investment, and it helps the student to make that connection, to open up that black box and have an understanding of what's happening in a fully general case. Once we have that investment, as I've kind of attested to already, we'll make use of those techniques in that review in the linear regression model context. So we'll cast everything in terms of vectors and matrices. We will enumerate some assumptions in the classical linear regression model, things like mean independence, things like different maintained structures for the variance-covariance matrix, and then we'll talk about estimation, leading us, of course, to the familiar OLS case. One topic that I particularly like to emphasize is coefficient interpretation. So often we throw around casual language that in multiple regression settings we know we get cleaner estimates of the effect of some x on a y because we're able to control for a variety of other potentially confounding factors. At least in my case, my understanding of that was rather casual until I was exposed to a linear algebra-based treatment of econometrics. And the goal here is to kind of shore up that casual understanding formally, to introduce some mathematics that leads you to that exact interpretation. We'll then apply those properties that we enumerated previously, consistency, convergence and mean square, convergence and distribution, and apply those to the OLS case. The course will conclude with a gentle introduction to nonlinear models. Specifically, we will review different models for binary choice problems. For example, there are many cases where the outcome of interest is a 0-1 random variable, perhaps something like whether or not you purchased a car in the past calendar year, whether or not you voted for a particular candidate in the previous election. So in all those cases, what you're trying to model is a binary random variable. If we apply the very familiar techniques, the OLS techniques that we've just finished discussing, that leads us to what's known as the linear probability model. It does have some deficiencies, and that leads us to the next two here, which are the probit and the logit. However, to consider those two alternatives, we have to move beyond linear settings and then discuss nonlinear ones. So here we will talk about a little bit of the theory behind these models, a little bit of their structure and coefficient interpretation within that context, as well as some applications. So I thank you very much for your time. I think Econ 571 is a really exciting course, as well as our master's program overall, and I very much hope to have the chance to see you in 571.